So the question is product of array except self. So given an integer array nums, return an array answer such that answer of I is equal to the product of all the elements of nums except nums of I. So basically we need to write an algorithm that must run on O of n times without using the division operator, because if we would have used the division operator then it would have been very easy. For example, let's say 1, 2, 3 and 4 are the elements. If we just straight up have a product of these elements, we would get 24. So for every element, if we would have divide 24 by that current element, say 24 divided by 1 is 24, 24 divided by 2 is 12, 24 divided by 3 is 8, and 24 divided by 4 is 6. That would have been answer. That would have been very straightforward. But we can't use the division operator here, so this method won't be working. So what the brute force solution says here is we can use two nested loops, one I starting from 0 and a j starting from here is 0, and we would traverse j on every iteration of I, and we'll only skip the iteration where I is equal to j, and then we can have a product value that will be updating the current ith element, updating the ith element in the answer by finding the product multiplied by the j value. Suppose I is here, j starts here, and the product value is 1. Now when I is equal to j, we do nothing and just move the j value. Now we can have the product as product multiplied by j, that is 1 into 2 is now it's 2. Now we can increment j again. Now product multiplied by j, 3 into 2 is 6. Now we can increment j again. Now 6 into 4 is 24. So we know that at ith index the answer is going to have the value 24, and then we can move I, and then we can do the traversal of j all over again, and so on. But this method will be taking time complexity of O of n square, which we don't want, as the question clearly states we need an algorithm to run on O of n time. So how can we optimize the approach? So our method 2 says what we do is for every element we store the product of all the element that comes before and the product of all the element that comes after the element. So for example, let's take 3 here. So before 3, the product of 1 and 2 is 2, and the product of all the element on the right of 3 is 4. So we need some way to store these two elements. So we can use a prefix and a suffix array to store this. So what we do for the first index, the 0th index, what we need to do is nothing comes before the 0th index, so we can by default put 1 here, right? And for the next index, what we can do is we can multiply the previous index with the previous index of the nums. So here 1 will be multiplied to 1, that is 1. So what happens is if you come to 2, before 2 the product of all the element is 1. So we store it here as 1. So moving forward to the second index, what we do is we multiply the prefix of the index minus 1 and the nums of the index minus 1. So we'll be multiplying 2 multiplied by 1, that will be 2. Like that, you can see if we are standing at the third index, then the product of all the element before the third index is 1 multiplied by 2 is 2, is on the second index. Same goes for third index. So what we will do is we will multiply 2 with 3. So 3 multiplied by 2 is 6. For suffix, we will do the same thing. Only thing is that we will be starting from right to left now. Why will we be doing that? because we are going to store the product of every element after it. So let's suppose 4. After 4, there comes nothing. So we can by default put 1 here. And in the same way, what we are going to do, the index we are at second index. So what we will do is multiply the index plus 1. What we will do is we will multiply suffix of index plus 1 with nums plus 1. So here 4 will be multiplied by 1, that will be 4. Similarly, at first index, we will do is suffix of index plus 1 multiplied by nums of index plus 1. So 3 will be multiplied by 4. So it will be 12 here. Similarly, at 0th index, suffix of index plus 1 multiplied by nums of index plus 1. So 2 will be multiplied by 12 is 24. So for storing the answer, what we will be do is we will be traversing on prefix and suffix, and we will be multiplying the values at every index. So what we will do is we will be multiplying this, this and this. So what we go here is, so answer at 0th index, it will be suffix of 0 multiplied by prefix of 0. So 24 multiplied by 1 will be 24. Similarly, for first index, it will be 12. For first index, it will be 12 multiplied by 1, it will be 12. Similarly, 4 multiplied by 2 is 8 and 6. So there we have our answer. So the time complexity for this solution will be O of 3 multiplied by n, as we will be traveling the array of size n 3 times, one for the prefix, one for the suffix, and one for finding the answer. So it will turn out to be O of n, and the space complexity will be O of 2 into n, as we will be storing an additional prefix and suffix array that will be turn out to be O of n.
Okay, so we can create vectors. For one we'll create for answer of size n, we'll create one for prefix and one for the suffix, and then we can make prefix of 0 as 1 and suffix of the last element as 1. Then we can just store n as the nums dot size, and now then we can traverse into the first prefix array starting from the first index up to n, and what we'll do is prefix of I is equal to prefix of I minus 1 will be multiplied by nums of I minus 1. Now for another loop for suffix starting from n minus 2 coming up to 0, it will be a decremental loop, so suffix of I will be equal to suffix of I plus 1 multiplied by nums of I plus 1. Now we can you do the answer traversal for I is equal to 0 to n. So answer of I will be a multiplication of prefix of I multiplied by the suffix of I. Then we can just return the answer.
So how do we optimize this further? Prefix and suffix array altogether, what we can do is we can directly store all the values into the answer. So how are we going to do that? So first, let us store the prefix values into the answer. So when we traverse into this array, what we will do, keep the first value as 1, because before 1 there won't be any values. So what we can do is now we can multiply the answer of 0 multiplied by the nums of index plus 1. So this we can multiply this value with this one. So 1 into 2 coming into the second index. So what we will do is answer of I minus 1 multiplied by, so this multiplied by nums of I minus 1, that is this. So we will multiply these two values. So 1 into 1 here will be 1. Same for this. For second index will be answer of index minus 1 multiplied by nums of index minus 1. So 2 multiplied by 1 is 2, and same for this value. So answer of index minus 1 and nums of index minus 1, that will be the product of these will be 6. So we have created our prefix array directly into the answer variable. Now what we need to do is to calculate the postfix, or you can say suffix. So what we will do is, rather than creating an array, what we will do is to take a variable. Let's take suffix as a variable and initialize it with 1, because for the current index, any the product of all the element after this is going to be 1. So we'll be starting it with 1. So just like the previous approach we did, we'll be starting the suffix from n minus 2. So we'll be starting it from this index. And what we will do is, so to calculate the suffix, we'll be having two steps. So the step 1 will be that suffix will be multiplied by the nums of I plus 1. We'll see how that goes. And the second step will be that answer of I will be multiplied by the suffix value. So let's take an example. So just like the suffix we did in the previous method, we'll be starting it from n minus 2, so from this index. So what will be the suffix will be multiplied, so suffix here is 1, will be multiplied by the I index plus 1, so this index, so it will be multiplied by 4. So suffix is now 4. His answer of I, that is 2, will be multiplied by suffix. So it will be 2 multiplied by 4, which is equal to 8. So we can add 8 here. Now moving on. Now moving on to the next index. So I is at the first index and the suffix is 4. So what we will do is suffix multiplied by nums of I plus 1. So this value. So 4 will be multiplied by 3. That will be 12. Now the current suffix will be multiplied by the answer. So 1 into 12. So we can add now 12 here. Next we can move to the 0th index. Now the suffix is currently 12 and the I plus 1 index is value 2. So 12 will be multiplied by 2. It will be 24. Now the 24 value will be multiplied with the answer of I. So 1 multiplied by 24. So this will be 24. And like that, we have got our answer. So what we did here was we directly calculated the postfix once in the answer directory. Then we use a suffix as a variable and then use these two steps to actually put the values into the answer to get the final answer. So this reduces our time complexity to O of 2n, that is still O of n, and we have now got the space complexity down to O of 1.
So we create just one vector here of size n, initialized with all ones, and we initialize n for simplicity. And now we will traverse for I is equal to 1 up to n, and what we will do is answer of I is equal to answer of I minus 1 multiplied by nums of I minus 1. That is, our prefix array is done. Now we initialize a variable postfix as 1. Now for I is equal to n minus 1 and I is greater than equal to 0, a decremental loop. So answer of I will be equal to answer of I multiplied by the postfix, and postfix will be multiplied by the number nums of I. Then we can return the answer.